and we will go from there.
Hello, my name is Greg Lewin. I'm the Associate Head of the Robotics Engineering Department, and we'd like to welcome you all here. And we're gonna take some time to explain to you what robotics engineering is all about. And if you have any questions, we'll be happy to answer questions in the background.
I'll jump in now. Then my name is Ken Stafford. I was one of the early adopters of the robotics program at WPI, part of the group that established this program, and I get the privilege of doing most of the talking today. And I see that our director has popped in, so I'll let her talk. Introduce yourself. Can't hear you, Jing.
Yeah, I cannot see you, but maybe you can see me. Yeah, I'm Jing Xiao, professor and head of the Department of Robotics Engineering. Welcome. Very happy to have you here to learn more about our program. And we'll have Professor Stafford as the presenter here first.
And I see we have Kalina on board too. So Kalina, would you introduce yourself?
Yeah, hello everybody. My name's Kalina. I'm a junior RBE student, set to graduate in 2023. I'm also doing the BSMS program here if anyone has specific questions about that.
And we have one other student that may or may not show up, and that'd be Annie. She's also a junior in RB, but a double major in CS as well. So we'll see if she does show up here. In the meantime, I guess I'll get started with this presentation. And again, I want to, for the sake of all of us, professors and students, welcome to this presentation. We wish you were here to see our campus. It is a lovely campus. You know, fall time colors are spectacular, but it's also nice in spring when there are the flowers blooming and the fountains are working and all of that. You know, the campus is kind of unique in that it used to be called one of the most wired campuses, and then it became one of the most unwired campuses. And now, of course, it's one of the most robots, I think. We like to think that there's one robot at least for every 3 students, but there could be more than that. But let's just get back and talk. I want to talk quickly about some of the things you would see on campus if you actually were able to come here, and maybe you have been here. Hopefully you will get a chance to come. But if you look, there's some spectacular new buildings. I just want to go quickly through some of these new buildings and give you some context about them. The Sports and Recreation Center is really new to me, but you know, I guess it's about 9 years old, but it's still one of the latest things on campus. And then of course there is the Innovation Studio, which is only 3 years old, which is a highlight also of our campus in terms of the capital investment and the cool things that are going on. And the latest thing that will happen, which is just in the spring of this next coming year, is the new Smart World building, which is really going to be spectacular. It is nearly completed now. I know that our Professor Zheng Zhao and others are planning on making the move into there. But here's the things that are interesting. We have all of these big capital investments on campus, and yet every single one of them, incidentally, has been built to accommodate robotics. Now, here you'll see the Sports and Rec Center, which I like to call the Sports and Robotics Center, because there's 13,000 square feet of this building, which is designated and apportioned for robot pit area, which is pretty big investment for that. If you look at the FOISI or the Innovation Studio, there's only one department that has a fixed presence, and that is the robotics department. This is a picture of the lab in which Professor Lewin and others will be teaching the academic undergraduate courses. I think this is like maybe a 2000 RBE 2001 project perhaps, but that's how important robotics is. And of course, the cool thing about the latest and greatest building to open up this spring is that that's where robotics engineering will be headquartered, because it is certainly part of the smart world, and we need to be right there in the newest building on campus. And so that's what you can look forward to when you come next fall. But we'll look back a little bit on robotics and just to kind of give an overview of why we think it's important and why we think you'll be excited to come here if you do. Obviously, robotics it's new stuff, you know, and in fact, it's been new stuff for a long time. Back when I was an undergraduate student, not WPI, unfortunately, but nonetheless, you know, there were robots, but they weren't very cool. And so WPI decided that robots were essential. In fact, we established our first robotics laboratory in 1965. But this was the kind of robot that we were dealing with. These were industrial robots that were really making manufacturing processes safer and faster and frankly better starting from the 60s. But then this little guy right here, this is the Roomba from iRobot. It began about the same time most of you were born, around 2002. And currently there are over 30 million of these sold. This is the one that really brought robotics into a consumer department. Even before this was built, though, iRobot built this, which was the PackBot. And of course, many of you may have known that the first time it was deployed was during the September, the September disaster at the Twin Towers. It was used for searching through the rubble for survivors, but it's been used a lot since then. But beginning from about 2011 and on, robots start showing up in all sorts of other places, in all sorts of media, underwater, on the water, in the air, and so that all led to us thinking, now is the time to get started in this thing. And so we actually started our program now, like I guess 13 and a half years ago or so. That was when we opened up our Bachelor of Science department, quickly followed, as you can see, by a Master of Science and a PhD program. And so most of you would know this, but frankly, we're quite proud to have been the very first university in America to have a Bachelor of Science degree in robotics engineering. And of course, consequently, we were also the first university to have all three of these levels of programs. It's one thing to develop a program. It's another thing to suffer the close scrutiny of what is most significantly useful for understanding how engineering and technology should be approved. And this is the accreditation board for engineering and technology. We submitted and we were accredited on the very first time. And so the interesting thing about this, for those of you who don't understand how ABET works, is that since we were the very first program to have robotics engineering undergraduate program accredited, it means that anybody else who decides to develop a program now kind of has to follow our lead. It was quite surprising that we were able to do this, but they didn't think we could handle that kind of a integrated program and make it cohesive and complete in just 4 years. And in fact, remarkably, they awarded us with the first ever innovation award for that robotics engineering program. So we're pretty pleased not only to be accredited, but be recognized now nationally as the place that knows how robotic engineering should be taught, and have been doing it very well. Backing up a little bit though, it's interesting to think about why New England would be the start of this. Helen Grainer was coincidentally part of our initial advisory board when we decided we need to figure out what the industry and what society needed for robotic engineers. She was also, of course, the co-founder of iRobot, Sci-Fi Works, and a bunch of other companies. And she frankly understands that, yeah, New England, it is the center of robotics. It is really the Silicon Valley of robotics. Now, if you look at some of those numbers here, when I first made these slides like a dozen years ago, I remember saying over $2 million of robots have been sold. And I just checked it last spring, it was over $2 billion now. And indeed, if you look just at Boston, there are 52 robotic companies there. And most of them have started since we started our program. So it's really an up and coming and growing business. And again, I checked last spring to figure out what was going on, and there were 135 open spots for robotics trained folks. And the average salary that they were looking for was about $129,000. If you look at Massachusetts and New England, and you'll discover that it's not just Boston, it's everywhere. Robotics, either industries or research or test sites are pretty much everywhere scattered in New England. So it's really quite surprising. Now we can look back and understand that it's not just a US or regional affair, it's really a global sensation. There were $24 billion worth of robots procured in just 1 year in last year, 2020. And they say that globally right now there's 150,000 jobs for roboticists. Now, most significantly, in a recent worldwide business investigation, they discovered that 88% of all global companies have robotics and automation as part of their long-range strategic plan. So it's a good place to be. If you think about robots and understand that it's not just the the welding robots or even the vacuum robots, they're in almost every place you can think about, and they look a lot different. In fact, even the ones that are on our campus, which are some of these early ones here, they all look distinctly different. So it's really interesting to question, and we did do this thoroughly when we started this program. If we're going to have robotic engineering, how do we describe it? How will people know what they're going to be doing? And as an anecdote, when we asked this question in one of our very first industrial advisory boards, there was just like this quizzical look amongst these people. And then someone said, wait a minute, yeah, what's a robot? Well, they're hard to describe, but you know one when you see one. And that's not really satisfying for academic development. So we thought we'd be a bit more rigorous. And so we said, it's all about sensing what's going on around you. In fact, once you've made smart perceptions, then you can do some computations based upon those smart perceptions. And then most significantly, it has to result in actions, because otherwise it's just a thought process, a virtual game. And it has to actually be in the real physical world. Now, the key thing is that once you've done that, you have to have a little feedback on there. So understanding that, did you do what you're supposed to do, or have you gone too far? In other words, make some corrections. And so this is what we thought about it. In the words of our program director, in fact, it can just be combined to say, hey, we just want to have an intelligent connection between perception and action. So this is what we define a robot as being. Now, if you look basically at the historic reasons why robots were used, it was because of this. And that does describe a very one aspect of what robots are used for, but things have changed dramatically luckily for you folks and for us, because if you think about it, what is it in this perception business and this automation business which really gives robots the capability of doing stuff? What are these enablers? These are what we think are enablers. Now, those you're young and you understand that GPS has been here forever, all these sensors have been here forever, but the truth is, things have changed a lot. That very first portable GPSs were only around about 25 years ago, and they cost $10,000 a piece. Today, every smartphone basically in the world has a GPS, and they cost about $4. Now, some of you may understand that one of the biggest reasonably recent robotic challenges was one of the DARPA Grand Challenges. This was the automated driving across the deserts of California. It was amazing. It took a couple of years for it to happen, but it was, if you looked at that and followed that, one of the most distinct images were these vehicles with these big rotating, spinning LiDARs, which is a laser detection and ranging system on top. And in fact, if you look at any of the self-driving cars, you see these big spinning LiDARs on there. Well, 15 years ago, those cost $75,000. I just checked. And in fact, as of a month ago, the same company that made those $75,000 ones now is selling solid state ones for $100. So everything that makes robots powerful, the cost has gone dramatically down. And of course, it's no longer just used by things that are dirty, dangerous, and difficult, because everybody wants them. About 4 years ago, awkwardly enough, both Apple and Google came to visit campus on a recruiting. And they told me and others, said, we will hire every one of your robotic engineers. And the answer was why? Because of transportation, self-driving cars. So everybody wants robotic engineers. Now, when we thought about robotic engineering, we said, what's unique about it? What is the character of robotic engineering? Well, it's fundamentally multidisciplinary. It does combine aspects of mechanical, electrical, and computers, obviously. And also, you have to understand a little bit of how to use these in a good manner, these different disciplines, which means systems engineering is part of that too. It also occurred to us that if you're really going to build stuff, you really need to have equal footing on understanding all the theory, but also have a practical understanding of how things go together and what makes them useful or not. It is important, we believe, to have current and topically, meet the requirements of what the world is coming through. So this means you have to have close relationships with people who are going to be end users and smart folks that can talk about those. Well, WPI has this history of all of those aspects. We've over 50 years, we've had the plan, which is an innovative project-based education, which has incredible flexibility. So it allows different departments and disciplines to work seamlessly together. It also has historically strong connection with industry. We have folks all the time that are demanding our students and giving them really good projects to work both once they graduate and even in school. So we have that going for us. And then of course, it doesn't hurt that we have decades of relationships with some of the big robot players, both in the high school world, which you might think about as FIRST and VEX, but also in NASA. We've done really quite well with a lot of their robotic challenges. So we thought we were pretty solid. And again, I told you that we started in 1965 with robotics, our first robotics lab. And in fact, that's the only lab we had until the year before we started our program. That one course, one lab, there was one faculty member, and of course, there were no true robotics students because that was an offshoot of manufacturing engineering or mechanical engineering. Today, things have changed quite a bit. We have this, we've got, I did a count, and I think I counted a few more than even my colleagues have. I counted 22 labs on WPI that are robotics. And here's the number of courses. The number of folks we have that are actually core now and affiliated is a moving number, because I know that Professor Yao is constantly hiring more. And so that's great, because we are a fast-growing program. These numbers are kind of approximates on our current undergraduate and graduate students, but suffice to say that we have been the fastest growing undergraduate program and the fastest growing graduate program that WPI had ever seen. We have certificates, so we have all 3 degrees, I said, plus, as of last year, we had gained full department status, the first university in America to have that. And we get funding for our research from all these agencies. And I'm talking funding for graduate school, but also not unusually for undergraduate projects. So you guys came, you're interested in WPI because you've heard about WPI roles. So let me just review some of the things that you may have heard about. This is about half of our WPI prospective students have had some high school robotics on them. This, if you don't recognize it, was a picture of 2007 on Einstein and the first championship, the world championship. And it just happens that the alliance captain of the winning worldwide tournament was sponsored by WPI. That's team number 190, which is down there in the bottom. And that symbol right there means you just won the world championship. It was a proud moment for us. WPI students took charge of robotics even before we did academically, and in 1998, through a student project, they developed this thing called Savage Soccer, which has been going on continuously ever since, which is a student-driven competition for high schoolers that's held on campus every year. In fact, it's been held in several places around America now. California, Connecticut, New Hampshire, and Iowa have held the WPI Savage Soccer, and it is a free, low resource robot tournament just for high schoolers. The robots they come in smart and come in not so smart, but well built. And you may recognize this. This was a bike force, supported and built by a WPI alum, a 2-time winner of the Battle Boss Championship. It was interesting and fun to watch. That same student built this, which is one of the very first NASA robotic challenges, which was set up in 2009. That student was one of my advisees. And as a sophomore at WPI, he won this NASA Centennial Challenge and won himself $500,000. It was really quite exciting. Here's another NASA win we had. This is a picture of 2 students, myself, when we were at the Johnson Space Yard in Houston, Texas. And here we are displaying the rocks that our little robot there managed to pick up, and won that first ever RoboOps Champions, which is a university challenge to operate on surface like the Mars, and then remotely pick up samples of interest and then return them back to a launch area. I'll talk a little bit more about this later as we develop this into another research project. This is one of the DARPA challenges we did extremely well in. After the nuclear disaster in Japan following the tsunami, there was a DARPA challenge to develop a robot that could handle a nuclear disaster and go in there safely and turn things off, adjust controls. And so that was our robot. It's that robot's still on campus. It is a robot built by largely the chassis built by Boston Dynamics, but it's our WPI version of it, and it's done incredibly well. If you're a local person, a New Englander, then you must have heard of Battle Cry. 21 years we've been running this tournament for high school robotics. It's now the most popular off-season robotics tournament, arguably in America. It fills to capacity roughly 70 to 80 seconds after we open up the registration. I got to say, we come in robots in all sizes, but just a little bit of a ping here. We are 2-time world champions in the sailing robot contest. And so that was one of my personal projects, and I really do think that's great fun. If you've watched BattleBots on television recently, you've seen that we have a undergraduate sponsored team there that's building Ribot. And in fact, there is a new season that will be broadcast very soon, and be sure to watch it. WPI is prominent on that. So we have all these things which are getting us publicity, which is wonderful. And perhaps that's one reason why you'd be interested in WPI. But let's talk a little bit about what you'll get if you come here. Basically, the curriculum is designed to put all this really good stuff into a 4-year program. And that's not easy, because initially when we laid out the program, it ended up being 6 years long. We said, that's not bad for tuition, but we didn't think that probably we would have enough people that would really want to stick around for 6 years. So we very innovatively decided and spent a lot of time crafting this, and this has been working out quite well. So we do introduction courses, but we let most of the supporting departments do their intro course, with the exception of RB. We have our own intro course there because they do it well. And then we combine all the intermediate level courses into this really cool program, which is called Unified Robotics. And that happens mostly your sophomore, junior, and/or senior years. And this is where all the intermediate level of computer science, mechanical engineering, electrical engineering, and robotics come together, all connected with the robotics context. And those graduate in from simple little robots to really advanced pathfinding smart robots. At the same time, in this section, you'll be doing intermediate courses in your mathematics and your pure sciences, all the ABET requirements to make you a fully charged technician. And then there's a lot of room for advanced courses that you can take depending upon your own desires and the fields you like to. And we'll go back through that schedule a little bit later. And then all culminates in a capstone project, which again, I'm going to show you an example of that at the end here. So that's basically how it works. Here are the core courses. You can see the Unified Robotics there, the Introduction to Robotics, which is both Professor Lewin and I, well, he's still teaching, and I always did teach that. It's a lot of fun. And then you can see some of the other courses that are here. There are a bunch of these X courses, and those are courses which are experimental because we're always developing new courses. And if they, these are ones which have currently been under experimentation, which means after a year, if people like it and we settle it up and it becomes a new course. We're always innovating, always developing new courses to keep up with what is happening with robotics. Here's a list of electives. And for those of you who are really astute, you'll recognize, well, wait a minute, these all have 500 prefixes, which in most schools, and indeed at WPI, connote graduate courses. Well, we bring them here because we want you to know that you can take these as an undergraduate. That WPI has a very, very flexible curriculum, and allows you to do things when you think you're ready, not when there's prerequisites established, because frankly, there aren't prerequisites for our courses. And so these are some examples of some of the higher level courses that people get into. A lot of fun if you're capable of doing it, and you do it. But let's get back to an undergraduate program. Here's what it looks like typically. And then be aware that there's an incredible amount of flexibility in this, because it turns out that a lot of students, perhaps most students who come to WPI, come with advanced placement of some sort or another. So you wouldn't start necessarily with Talk 1 or maybe Physics 1, but here's an example of what could happen. I've highlighted those courses. There are 4 terms. You probably recognize that. And I've highlighted in yellow those that are RBE. And because it's important that you understand that we get you into RBE your first year. And each of these yellow courses, you're actually building a system. Sometimes it'll be a complete robot, sometimes it'll be a program, but you're actually building stuff that's robotics. So it's a lot of fun. And please do recognize, you see down here toward the junior and senior, there's just a whole lot of elective space here for you to customize your robotics education and what you think is passionate, what you're passionate about, what you think is important. So that's kind of what it could look like, but there's a lot of flexibility in here. Now, if you're looking at WPI, it means you're probably looking at other schools as well, because it's a competitive market, and if you're looking at WPI, it means you're probably capable of going to a lot of other schools, and frankly, there's a lot of schools which operate and have robotics, but the majority of them you'll see they'll be offered as concentrations or some subset other than a major degree by itself. There are, I think at my last count, there are about 4 or 5 schools now which actually do have, following our lead, they now have a degree in undergraduate degree in robotics engineering. But nobody else has the experience we have this, because we've been doing it longer than anybody else. And as I said before, we were the first school to establish a formal, fully fledged robotics engineering department, not a subset of mechanical engineering or computer science, but a fully standalone department. We think it's that important. Now, here's where I have to be a little careful, because I don't want to step on our admissions people's toes. But I have to say that even though there's so many good reasons why our robotic engineering is wonderful and very entertaining, I would encourage any student coming here to understand that it's even more paramount in the decision process would be understanding why WPI education is different. It has to do with the fact that we have the WPI plan. And so if you're not sure about that, I really encourage you to understand all the differences that are associated with the plan that based upon collaboration, not competition, that doesn't penalize you for early, smart failures. There's no penalty for doing poorly. It just disappears off a record. We believe that you make smart failures early so that later on you don't have those non-successful projects. You learn from those. But please understand, and when you come to campus, read about the plan and understand why it is distinctly different. Okay, everybody loves the things we do. Robots are expensive to build. Even at the undergraduate research, they're expensive to build. So we have folks that really, really want to put their names on our robots, and they're willing to give us projects to work on, funding, resources, so that we can continue that up. Here's a few of those folks that have provided us with projects and funding to advance undergraduate projects. Our undergraduate projects go the gamut. As long as it meets that little paradigm of what we described a robot is, then it fits in here. Here's just a few that I picked out here. But I wanted to show you one project. We do have a requirement for folks to put together a 1 or 2 minute video of their project. And here's one that I was associated with that I really like. Now, before I start, I'll play a little video of it. Recognize that it was based upon that same NASA challenge that I earlier showed, the 2 students myself on top of the hill with little colored rocks. That was called the NASA RoboOps competition. And let me remind you what the competition was. It was to take a robot down to Texas and have it in 1 hour, have it drive remotely around a various lunar simulated surfaces, Martian simulated surface, asteroid simulated surfaces, and find these special samples and bring them back to a launch pad. And the only rub, which was interesting, is that the robot was down there, but the remote control driving all had to be from your home campus. So we were operating the robot from 2,000 miles away via 3G phone connectivity. So it was a real challenge. So here's what they came up on the second year after that. And so you'll see that there were 4 students on here, and we had 3 advisors. And it looks a little bit more finished than the first one we had, but it had to be able to go over rough terrain clearly. It was the same folks that built that first one, but here they had time and energy and got academic credit for it. A lot of planning went into it, of course. And like almost all projects at WPI, they built it themselves using all of our manufacturing facilities. We have an incredible technological lab. They've learned to work pretty fast. This had to be built in 3 terms of work. We do believe that the theory and practice go together. So you'll see down below the MATLAB approximation of it. And then here it is doing what it does. Testing is part of any project. And so this thing had to be able to go over rough terrain and had to be able to survive under some moisture considerations and sand and all of that. But principally, it was designed to be a lunar, or excuse me, an extraterrestrial vehicle that can be modified based upon your mission. So here they are putting on a camera mast and the cell phone connections. And so now it can be driven anywhere in the world, including there in Texas, by a remote operator like you see in the left-hand corner, simply by using this camera and then sending it commands through it. And of course, wheels can only go on terrain. It can't go on stairs, of course, unless you have a really good robot. And so you can see here that we have no problem. That group had no problem going upstairs with this rocker system in its chassis. So that is an example of one of the MQPs that I was working on that I was quite pleased with. But you can see our folks are getting internships and jobs basically anywhere you can imagine that builds those things. Okay, so it's time for us to start answering some questions. I'm sure that folks have already done some of those things. So that's the end of my formal presentation, and we're here to answer questions now. So, Greg, have you been answering questions here along?
Yeah, it looks like there was some questions about the BSMS program that I don't know if people, our students want to share a bit about, or Ken, if you wanted to kind of address that more specifically.
I'm sorry, which one? Which program?
The BSMS program.
Oh, well, I can be glad to share that. Oh, I see Annie's on here. I think Annie, you are in that program. Is that correct, Annie?
Yep, I am a BSMS for RBE and also double major for CS.
So would you like to say a few comments about the MSBS and actually dual major programs?
Sure, so you usually decide whether you want to enroll in the BSMS program by the start of your junior year. And I applied during winter break because I had time then, and it's rolling admission. So I applied, and then within a few weeks, I got a response being like, hey, you were admitted to the BSMS program. And the BSMS program allows you to double count your undergraduate degrees into your graduate degrees so that most students can finish both their bachelor's and a master's in 4.5 or 5 years. So in my opinion, it fit my schedule pretty well, and I think it's a pretty sweet deal because in other places you'll get a master's in 2 or 3 years. Yeah.
Let me just add one thing about that is that every freshman is going to be assigned an advisor, and so I'm sure that Greg and I, Professor Lou and I have had our share of advisees. I typically would have about 60 students a year as advisees, and I will tell you that in my background, I did a survey, and at least 40% of all of my students will end up taking a double major in 4 years. It's fairly common if you have folks that come in with APs. Is that great? Go ahead.
Yeah, so I can read the questions as you guys don't have to watch it, but another question for the students: do robotics engineering students have time to participate in social activities on campus outside of academics?
Colleen, you want to answer that?
Yeah, I can take that one. I just started typing an answer, but yes, absolutely. I've been involved in the VexU team since my freshman year. I decided to become an SA or a student assistant for robotics classes last year. There's definitely plenty of opportunities to be involved in any sort of social activity you want to be involved in, whether that's within the robotics community or other clubs outside of it. So yes, it's a definite yes to that one.
Just to add on to that, it's a great way to meet people outside of classes. Where sometimes we're in Washburn very, very late at night or very early in the morning, depending on how you look at it. It's a great bonding experience. A lot of my friends are in combat robot, and that's where like the very tight-knit group form, and that's how you spend like your 4 years just having fun with those kind of people. I'm also an SA for the 3000s class, and just helping people and learning as you teach other people is also a great experience, and also a great way to make connections as well.
Great. And then Ken, if you wanted to elaborate more about the advisor, someone's asking if students are assigned an advisor from the first year.
Yeah, we developed a program in 2000, which is called the Insight program. An Insight program pairs every freshman with an advisor, and it's not associated with your major because, frankly, WPI has no reason. We don't compel you to declare a major before you come here. Every student at WPI is prepared, frankly, from admissions point of view, to take any major they want to. But as a freshman, you're going to be assigned an advisor who just collects students who live in the same community. In other words, could be a floor of a dorm or whatever. You'll have like 20 or so students, and you'll develop a very, very strong relationship with not only that inside advisor who's going to be a faculty or staff member, but also a community advisor who's going to be a near peer that was maybe a year ahead of you, and a resident advisor who's going to be another student who's going to be in charge of your logistics of that. So there'll be a 3-person team there that guides you through the process of getting oriented and getting acclimated to the WPI environment. And anecdotally, it's a lot of fun as a faculty advisor, because the challenge and the real thing we want to do is, by the end of the first 2 terms, the first semester, we want a student to know enough about the different academic programs that they can just say, oh, I do know now that I want to be robotics engineering. And so as soon as they make that decision, then their advisor switches over to an advisor in their major.
Perfect. All right, doesn't look like we have any questions coming in right now. I know everybody was answering them as they were typed, but I would encourage, if there are any other attendees that have questions for any of the professors or current students, to get those submitted. We are getting towards the end of our time.
I would add a comment based on what Annie and Kalina said about extracurriculars, is that, again, there's just an awful lot of students who come to WPI to pursue robotics or computer science or mechanical engineering or whatever, based upon some sort of connection with robotics in high school, whether it's VEX or FIRST or something like that. And one of the questions that often comes up is, can they continue that relationship? And as was explained, yeah, VEX-U is there. We've been associated with the university competition of VEX since it began. We also have very strong institutional connections with VEX. They provide us with lots of stuff. We provide them with lots of stuff. If you look at the people who actually work at VEX and innovation first, you'll discover that there's just a whole lot of WPI alums in there. In fact, more than half, I suspect. And then FIRST has always been a huge program for WPI. So as a WPI student, you can stay involved with those high school programs, either moving up to the university competition level, or mentoring one of the several teams, FIRST teams that WPI hosts and sponsors, or being associated with running competitions, or join the WPI Robotics Club, which does things like combating robotics. And so there's lots of ways that are extracurricular that you can still advance your fun and interest in robotics at WPI, whether or not it has an academic or not connection.
Perfect. I don't know if anybody else has anything they want to add before we sign off for the afternoon. Anybody have anything else they want to say before we round off here? All good? Okay, awesome. Well, thank you, professors and current students, for joining us, and all our attendees. I hope this was helpful for everybody. If there are further questions, definitely reach out to us in the office, admissions office, or to the emails that was provided in the presentation. And I hope to see some of you joining some of our virtual sessions over the next month or two. But thank you, everyone. We're gonna sign off now. Thanks, everyone.
Thank you, everyone.
Thank you, guys.